Over the past few days, we have talked about arrays. We have looked at some of the features and how, in conjunction with other features of the C# language, they have been very beneficial. But there's just one nagging point, that they are inflexible, and that's due to their fixed size. Now, there are going to be times, and by that I mean most of the time, you will want that flexibility. You will want to have a collection of values that you can add as many elements to as you want, and you just can't get that with an array. So, as I've said yesterday, we are going to talk about collections today, but we're not going to talk about features of the C# language, because collections are actually a feature of the .NET framework, but they are fundamental in just about any program that you're going to write, so we do need to talk about them. The collections in the .NET framework can be divided into two categories. The first are non-generic collections, which shipped with the original version of the .NET framework. And then the other group are generic collections, which were added in .NET 2.0. Generics are a feature of the .NET framework and the C# language, and just about every other .NET-enabled language. But we're not going to spend a whole lot of time on generics, or at least the underpinnings of generics, because we can spend a whole course on those. So we're just going to accept the fact that generics exist and they are a wonderful thing. Now, the generic collections that we are going to talk about reside within the system.collections.generic namespace. The original collections, the non-generic, live inside of the system.collections namespace, but nobody uses those anymore. In fact, Microsoft saw to the template for new C# files to completely remove the namespace from the using statements at the top of the file for the original collections. The generic collections are just far better because of type safety. Just like we can define a type of value to use with an array, we can do the same thing with generic collections, where we couldn't with the non-generic. And today we are just going to talk about two of the generic classes. One is a list and the other is a dictionary. And I chose these two because they are the most commonly used. Now, the list is a lot like the arrays that we've been dealing with, in that they are just a list of values. We can add to them or remove from them, but unlike an array, we can add as many values to them as we need. And to create a list, we first type list, and then we use some different syntax. And it will look a little strange, especially in C#, but you'll get used to it as you use generics more and more. We have an angle bracket followed by the data type, and then followed by the closing angle bracket. So it's kind of like the beginning tag of an HTML tag, but not really. So we have this list of string, and that's how you say it if you're going to translate it into a spoken language. List of string, or if you had int here, it would be list of int or whatever. So list of string. And then we need to name it. And we can't use names because our array is called names. So let's just call it names list. And to create this object, we use the syntax that we used when creating objects from a class, because these are classes. So we call the constructor as opposed to the syntax that we used when creating an array. So we use new and then the constructor. And we also have to specify the data type when calling the constructor. So it's list of string names list equals new list of string constructor. Generics are a wonderful feature of the .NET framework, but as you can see, it requires a lot of typing. And repeating ourselves is nothing new. We've been repeating ourselves every time we've created a new variable, but this is getting a little out of hand. We have list of string and then list of string. And whenever we actually use a dictionary, it's going to be more typing. Well, we do have the ability to use a keyword called var. And if you're familiar with JavaScript, you know this is how you create a variable in JavaScript. Well, it's kind of the same thing, and it gives you a feeling of that this is dynamic, but it really isn't. What's going on here is the compiler is implying that our names list variable is a list of string, because it's looking over here at the right hand side and it sees we have created a list of string objects. So whenever we compile this code, it's actually going to replace var with list of string. But the var is a nice way for us to shorten some of the variable declarations. Now, we can't use var as a return type. That's not going to be possible, but we can use it for variables. And I typically use var anytime I'm going to use generics because I'm lazy. I don't want to type generic classes more than once. Usually, though, if I'm going to create a string or create an int or XML document or whatever, I typically use those data type names instead of var. That's just my personal preference. But if you want to use var all the time, feel free. Now we can create a list in 3 different ways. The first way is what we've done here by calling the default constructor, but we can also specify the capacity. Now we're not locked into this capacity. The moment we exceed it, the .NET framework is just going to give us more room. So that's just the initial capacity. We can also pass what's called an IEnumerable collection. IEnumerable is an interface, and we haven't talked about interfaces yet, but we will in a couple of days. But every collection and array implement the IEnumerable interface. So we can pass an array to this constructor and it will pre-populate our list with those values. So that's what we've done here. But if we did not want to do that, we could do that later if we choose to do so by calling the addRange method. It too accepts an IEnumerable collection and we can just pass names. But if we want to do so on an individual basis, we could call the add method and then pass individual names. Adding individual values to a list is rather time-consuming. It's a lot of typing, and it's really not helpful. But keep in mind that this is a demonstration. More often than not, if you're using a collection, just any collection, you are populating it with data from some type of data store. It could be a database or a file or some other data stream. And you would be using a loop to read that data. So inside of the loop, you would just have a single call to the add method, and then you would be adding whatever data from that data store. So it's really easy to use and to populate. We just don't have anything to demonstrate that with. So to make things easy on us for this demonstration, I'm just going to call addRange and then names. Well, I guess we could have pretended that names was from a database or something and loop over it, but yeah, whatever. Okay, so let's look at some of the features of the list class. The first thing is very important. It tells you how many names you have within your list, and it's the count property. It's a lot like the names.length. Arrays have a length property. Collections have a count property. So if you want to see how many values you have, just use the count. Let's look at what else we have. Many of these things, you'll notice that there's a box followed by an arrow. These are called extension methods, and we will talk about extension methods later in the course. But for now, I'm going to get rid of them so that we can focus just on the class, the list class. And those extension methods live inside of the system.link namespace. So just by getting rid of that using statement, we can get rid of those extension methods. So let's go back to the top. Oh, that's names. We need names list. And we have add. We talked, clear. Clear is nice. If we have 100 values, it really doesn't matter how many values we have in our list. If we call it clear, it's going to clear out everything so that we start back at 0. So if we have 1,000 values, if we call clear, then those values are gone. We can't get them back. And we have a fresh list object for us. The contains method will return true or false based upon if our list contains that particular value. So if we wanted to do a search for James, then that would return true. But if we wanted to do a search for Jeremy, that would return false. So that's nice to have. Let's see, copy to count exists find and find all. This is also something that arrays don't have, but the list does. As I said, lists give, or collections give us many more features. So the find and find all allow us to write code to find certain values based upon a certain criteria. So if I wanted to find all of the names where the second letter was an A, like James and Jackie, we could write code to do that. We would do the find all method, and then we would have to supply what's called a predicate. And a predicate's just kind of it's kind of a function, really. But it's a small little piece of code to basically determine something for us. And I'm going to use something called lambda expressions. This is something else that we will talk about later in the course, but it's the quickest way to really write a predicate. And I just want to get each of the names where the second letter is an A, and that's it. So this actually returns a new list, and it will contain the names James and Jackie. So if we do var new list equals that, then we can write those values. Console.writeLine new list, and there is a method to convert a list to an array. So if you want to switch it back to an array, you can. And when we run this, we will see system.string. Well, the reason why we are seeing system.string, or basically an array of string here, is because the string array cannot be readily converted to an actual string. So in cases like this, and there's many cases, many classes don't have the ability to just be converted to a string. In the place of their value, the name of their data type is used. So in this case, we have a string array being used. If we had some other complex data type, it would list that data type as well. So we'll need to use a loop and print out all of these values. So let's do a for each for name in names list. No, not names list, new list. And I just used var where I said I usually don't. There's one other place I use var, and that's usually in a for each loop, because I don't really think about what values I'm going to loop over until I type the collection name. And so var just kind of saves me there. So let's do name. And as we run this, we will see James and Jackie. So by using the find all method, we were able to supply just this little bit of code. And I'm sorry for using the lambda expression, but it was just too easy to use. We'll talk about lambdas in a few days. But all we had to do was specify this little bit of code, and we could get the names that we wanted with the second letter being an A. If we were using an array to do that, we would have to write a lot of code. So using a list and using the find all method of the list really shortened the amount of code that we have to write. So let's see what else we can do. Names list, find all, find index, find last. For each will kind of be a for each loop. I have no idea why IntelliSense is popping up down there. It's kind of annoying. But for each will loop over that list and execute whatever code that we supplied. It accepts an action. If it'll pop up, yeah, an action, but we can specify that as a lambda expression. So it will execute that lambda expression on each element within our list. So that can be helpful at times. There's also an insert. We can insert at a specific index. We can also get the index of a particular value. We can insert a range with an index, and then, kind of like the add range. Starting at one index, we can supply an IEnumerable collection, and that collection will be added at that index, starting at that index. Last index of remove will remove a value. So if we wanted to remove James, we could do that, and remove would return true. But if we did Jeremy, it would return false. So we can remove things. We can also remove all based upon whatever code that we supply. So kind of like the find all method, how we supplied that lambda expression, we could do the same thing with remove all, and remove all of the names that had a second letter of A. So we could do that as well. remove at a specific index. We can also remove a range of values starting at a specific index for, so many values. Reverse will reverse all of the elements. So instead of James, John, Jennifer, and Jackie, we would have Jackie, Jennifer, John, and James. Sorting is nice as well. We supply an object that handles the sorting for us. So there's a lot of flexibility there. And let's see, I think that's really it for, trim excess. If we had just 2 items within our list, we could call the trim access and it will remove all of the extra values, because what a list does is actually use arrays, but whenever we need more space in the array, it creates a larger array for us. So whenever we create a list, I forget what the exact number is, but it's actually quite large of an array. And if we only have 2 items within that, it'll trim off all the rest so that we just have a list of those 2 items. But of course, if we added some more values to it, it would again create new arrays, but we don't have to worry about that. It does that all for us. So it would still be dynamically or dynamic in size. And that's about it for the list. Of course, there's a whole lot more stuff that we could have gone into, but I just wanted to point out some of the key things that you might use throughout your code. And whenever we factor in link to that, then there's a whole lot more stuff that you can do with it. So it is a very powerful class that you can use with your code instead of using arrays. It's basically arrays on steroids. Well, I spent far more time on lists than I really planned to, so let's say goodbye to lists and hello to dictionaries. A dictionary is a collection of key-value pairs. If you're not familiar with the term key-value pairs, you can think of a key as a physical key, and you just have this one door, but it has a lock, and depending upon what key you put into the lock depends upon what value you get. So you put one key into the lock and you get one value. You put another key in and you get another value, but these values are typically different because the keys have to be unique. So if you put the same key in the lock, you're going to get the same value unless if you change that value. So that's kind of what a key value pair is. And a dictionary is a collection of those key value pairs. So to create a dictionary, we first type dictionary like I've done here, and then we have the type parameters. And with a list, we just had one of those, which we used a string. But with a dictionary, we have 2. We have one for the key and then one for the value. So in this dictionary, we are going to have a collection of key value pairs where the key is an integer and the value is a string. So we couldn't have a key value pair of string and string with this dictionary, because this dictionary is strictly for keys of type int and values of type string. And we'll just call this dictionary. And we create it just the same way. We call the class constructor. Now, of course, we could use var here if we wanted to, and I'm going to do that. Now that we have a dictionary, let's add some data to it. So we use an add method. There is not an add range method for the dictionary class. And we need to specify the key. Keys have to be unique, and I'll show you why here in a second. Let's add a value at this key. So if we wanted to get this value, we would use notation that looks like index notation. And because we've used an integer as our key, it looks exactly like index notation. But let's say that we actually have a key of string. Oops. And let's use A. So now instead of an integer, we have a key of string, so we have to put a string as the key. And of course, this isn't going to work here, but we can do A because A is our key now. So the value of value is Jeremy. But if we add something else at the same key, it's no longer going to be Jeremy, it's going to be Jeffrey, because keys have to be unique. And since we use the A key already, it's going to change the value from Jeremy to Jeffrey. So that's the key value kind of relationship. You have a unique key that gets a value for you. And since this is a dictionary, we have a collection of values. So let's have A and B, but we're not limited to just single characters. We could also use any string that we wanted to as a key. So for the key A, the value is going to be Jeremy, but for the key Bill, the value is going to be Jeffrey. So we can use whatever value that we want as a key, and that's just how key value pairs are set up. So it doesn't have to be an integer or a string. It can be any data type whatsoever, and we can use that as a key or a value or both. As far as methods are concerned, there's really not a whole lot of methods for a dictionary class, but there are some helpful tools that come in handy every once in a while. We talked about add. First is the clear. It clears everything out of the dictionary. Then there's two methods called contains key and contains value. And this will return true or false based upon if that key or that value exists. It really doesn't care. If you're doing a contains key, it doesn't care about the value. So if you wanted to know if this dictionary already had a key of A, you would do something like that. And of course, that would return true. But if you did B, that would return false, because right now this dictionary does not have anything with a key of B. And the same thing for the value. It does it based upon the value. So if we did value Jeremy, that would return true. But if we did value Bill, that would return false, because we don't have anything with the value of Bill. We have something with a key of Bill, but not a value of Bill. And those come in handy every once in a while. Let's see what else. Count, kind of the same thing. It counts all of the key value pairs that we have. Keys is a collection of all of the keys. It doesn't give us anything about the values. So we have a list of all the keys available. We also have the values. So it's the keys or the values, not the keys and the values. We also have a remove method that accepts a key. It doesn't accept an index because everything is based upon a key. So we supply a key to remove a particular key value pair from this dictionary. In this case, we are removing the key value pair of A and Jeremy. And to loop over a dictionary, you typically use a for each loop, because it's really hard to iterate a for loop with a letter, or a string for that matter, or anything that's non-numeric. So for the most part, if you're going to loop over a dictionary, you are going to use a for each, because if you're looping over a dictionary, chances are you just want each of those key value pairs. And guess what you get whenever you do a for each loop? You get a key value pair. So I usually just call mine KVP, key value pair. So for each KVP in dictionary, we want to write something to the console. So let's do console.writeLine, and we will do KVP. There is a property called key. So we will get the key, display it in our console window. We will say that it equals to kvp.value. And whenever we run this, we will see A equals Jeremy, Bill equals Jeffrey. Well, that's going to put the plug in the jug for today's lesson. I apologize for all of the demonstration code, especially today, but the day before yesterday, really all of these days that we've looked at arrays. Yesterday, we actually added some stuff to our person class, but for the most part, it's been demonstration, and I apologize. But tomorrow, we are going to get back into writing some actual code. We are going to look at inheritance, class inheritance, because classes can inherit from other classes. It allows us to organize our code much like we do in real life. So I hope you're looking forward to that, because I certainly am. This is getting into some really cool stuff. So have a good day. I will see you tomorrow.